Howdy everyone, welcome to the tutorial video for chapters 13 and 14. In this video we'll go over some examples involving mass percent, molarity, titrations, and converting between all the pH and pOH and acid stuff, all those relationships. Alright, so let's get going. In chapter 13, mass percent, again, it's something that we don't use too often in the chem lab, but it does get used more often in, well, let's call it the real world. You go to the store and you buy things. This is where you're going to get it, or a lot of times in mass percent. So I want to do a couple examples with this. So 13.46. So two problems here where we're given two pieces of information and we're asked to find the other two in the table. So here we're given grams of the solute, we're given the mass percent, but we don't have the solution or solvent. So we'll go ahead and do that where we say, okay, mass percent is always equal to the solute over the total solution times 100%. And so in this case, we'd say, 22.8 grams over X. The times I'll just get rid of that will be equal to 0.120. So I got rid of the 100, moved it over. Then we're just going to cross multiply. Sorry, get my calculator. Cross multiply and solve for X. So that means X is equal to 22.8 grams divided by 0.120. That's 22.8 divided by 0.120. And we get a total mass of the solution of 190 grams. So that would fit in right here, that the solution is 190 grams. But then we want to get the solvent. Well, the solution is the solute and the solvent together. So to find that one, we just say, well, it's 190 all told. We subtract off 22.8 grams. And so we'll get a 2 bar the 1, 7, 7.2. Yeah, 177.2, and that will be that answer. Okay, so that's how you would do that first one. It's a little straightforward there. The second one I picked out because this is often the hardest one to figure out just because of how the math works. It's a little bit more annoying with the algebra, so we'll just kind of reset there. Where they give us the mass percent and the solvent, but we got to get the solute and the solution. So if we set that up, we'd say that, 15.3% is equal to the solute, which we'll call X, over the whole solution. Well, I don't know that number, but I do know it's going to be the 315.2 plus the X, right? Because it's the solvent and the solute. So they're the same number in both spots. And then that's times 100%. So now when we just move things around, we say that, 0.153 is equal to X over 315.2 plus X. Now we've got to cross multiply and distribute. So we'll get 315.2 times 0.153. So that's 48.2 plus 0.153x is equal to X. We'll subtract this from both sides to get all the X's together. And so we'll get 48.2 is equal to, what would that be? 0.847 X. X. And then divide both sides by the 0.847. And so 48.2 divided by 0.847. We get that X is equal to 56.9 grams. So that would be solute, right? X was our solute. So 59. What's up? Oops. Eraser. 56.9 grams, sorry. And then again, our solution is the whole thing together. So we'd say, okay, 56.9 plus the 315.2 we were given, and that will give us 372.1 grams. And if you want to double check and say, okay, yeah, just to make sure this works out, just 56.9 divided by 315.2. Oh, sorry, not 315.2. 56.9 divided by the 372.1. And yeah, that's the 15.3%. Just a nice way to double check things for these trickier ones. So, let me just plug them in, make sure I get back to my right answer if I was supposed to. So that's how you do those. Like I said, this is the trickiest algebra to set up, but that's how it works. If they just give you the solvent, you've got to remember to put the solute in both places because it's included in both places. All right, 13.61, we're going to calculate molarity. So for this one, they tell us that we've got grams of, looks like sucrose, that's table sugar, in a solution there. And we want to remember that molarity is always moles of solute divided by liters of the solution. So hey, we've got liters of solution. That number is going to get plugged in right there. But we don't have moles, we've got grams. So now we're just going back to chapter 6. How do we turn grams to moles? We use molar mass. So first step is to figure out what's the molar mass of this big thing. So let's see, the 12 carbons will be 144.12. The 22 hydrogens will be 22.22. 11 oxygens, I'm not sure. I'm going to multiply that out. Can't do that one in my head. 176. And so now we'll add everything up. That's a 4, 3, that 12. Carry the 1, 6, 13, 14. Carry the 1, 342, which, yeah, that makes sense. Grams per mole. So that, honestly, that was the hardest part of the problem right there. Now we're just set it up grams to moles. So 22.6 grams. Then we say, okay, that's 342.34 grams on the bottom, 1 mole on the top. So 22.6 divided by 342.34. We get 0.699 moles. And then we just plug it into here. Okay, molarity is 0.699 moles divided by 0.442 liters. 42. And we get that this is a 1.58 molar solution. So not too bad there. Just, when you see, okay, what am I supposed to, just take your time. Say, oh, it's moles per liter. How do I get moles? I turn grams into moles, like we've done 1,000 times before. All right, next problem is 89b. Now, this is a titration problem, which there will be similar problems, or can be similar problems, in chapter 14. But since titrations are normally done between a solution of acid and a solution of base, they'll show up in chapter 13 as well. So this question covers both chapters. But it says, determine the volume of a sodium hydroxide solution needed to neutralize this much HCl. Now in the problem, it did also give us the balanced reaction, or at least I think it did, so I'll write that out, that we had NaOH plus HCl. Now if they didn't, this would be step 1. Get yourself a balanced reaction. That will form sodium chloride and water. Okay, so it's a 1-to-1 reaction all around. But for this equation, we're actually going to use our titration equation, HA MAVA equals HBB MBVB, where the A's are the acid, the B's are the base. H's are how many protons are either accepted or donated, so how many H's in front for the acid, how many hydroxides for the base. The M's are the molarities, and the V's are the volumes. And because we're using this equation, we don't have to worry about changing volumes to liters. We can just say, nope, let's leave it what we got. So we look at this one. For the acid, how many H's? It's hydrochloric acid, right here, HCl. So that's 1. The molarity of the acid, they tell us, is 0.055 molar. The volume of the acid is 55 milliliters. That'll be equal to HB, how many hydroxides, which is 1. Then MB, well, that's, oh, well, no, we're actually not trying to find the MB, we're trying to find volume. So 0.150 molar. And then, yeah, determine the volume. So we were trying to find VB. How much base should we add for this? To get that by itself, the 1's fine. We're going to divide both sides by 0.150. 0.150. And then that will give us VB. So let's do it that. So 1 times 0.055 times 55 is 3.025. Then we'll divide that by 0.150, and we get an answer of 20 point, well, I don't know if it's 2 sig figs, then it would be 20, but I'll just call it 20.2 milliliters. And you can double check and say, does this answer seem reasonable? And it does, because if you look, okay, the hydroxide here is almost 3 times more concentrated. And on a 1-to-1 reaction, that means it should be about 3 times less volume. And yeah, 55 to 20, that's about 3 times less. So that checks out as a reasonable answer. So that's how all you have to do for titrations. Set up your equation. Make sure you look at your formulas to get the HA and the HB right. That will take care of balancing for you. Even if they don't give you this reaction, we still would have had 1H and 1OH. And then plug in the other information they give you. Right. And then our last problem for this video are the pH relationships, where I know we did this in class, but we're going to look at how do we take a number given and then convert it to all the others. The key equations here, I'll just write them at the top, is to remember that pH is the negative log of the H plus. In this case, they're using H3O, but it's the same thing. That POH is the negative log of the hydroxide, that the pH plus the POH will always equal 14. And then if we have to go the other way, that H plus is always 10 raised to the negative pH, and OH minus is 10 to the negative POH. There is that H plus times hydroxide equals 10 to the negative 14th, but you generally try not to use that one. It makes it a little easier not to have to use all the scientific notation. All right, so for this one, we need to type in that we want the negative log of 5.5 times 10 to the negative third. This calculator is not very scientific, so let me try that again. Yep. All right, and so if we do that, we get that the pH, which over here, that's the other thing with these columns, you may not be solving them left to right. But when we type in negative log of 5.5 times 10 to the negative third, negative log 5.5 times 10 to the negative third, that is equal to 2.26, so that's the answer you want there. From that, I'll say, okay, use this equation about pH and POH, that I'll do 14 minus 2.26, so this answer will be what, 11.74. And then next up will be I'm using a non-traditional scientific calculator, and this one, phone calculators are not great. This is why you should have a real calculator handy. I left mine in the office. Let's see what I can do here. 10, there we go. 10 raised to the negative 11.74. So that's what this is, 10 to the negative 11.74. And that is equal to what, 1.8 times 10 to the negative 12th, and that does seem reasonable because it, yeah, that would get me 10 to the negative 14th. So those are your 3 answers for this one. All right. For the next one, we're starting with hydroxide, but again, it just means we might go in a different order of filling in these boxes. but the process is the same. Figure out which equation you can most easily use to get another box, and then go on from there. So from hydroxide, it's easiest to get the POH. So for that one, I'll do negative log of 3.2 times 10 to the negative 6. So negative log of and we get 5.49. That looks right, yep. For pH, it'll be 14 minus 5.49, so that will equal what, 8.51. And then for the H3O plus, well, that's H plus is 10 to the negative pH, so 10 to the negative 8.51. So here, give me a second. 10 raised to the negative 8.51, and we get 3.09 or 3.09, 3.1 times 10 to the negative 9th. And that's good. Now the last column is it acidic or basic? We always base that off the pH. That's usually what we're used to. So for this pH in the first one, it's less than 7. So this would be acidic. And the second one, the pH is greater than 7. That one would be basic. All right, so hopefully just going over some of these problems, help maybe clear some things up. You can go ahead and get some help with them. But if you have other questions, remember, always email, go to tutoring, come in for office hours, get the help. All right, have a good day. See you back for chapters 9 and 10 and the end of the semester.